The installation, as described, does not meet the requirements outlined in the National Electrical Code. The core issue lies in the insufficient working space in front of the 2000 amp service equipment. While the general contractor attempted to address this by installing doors in front of each piece of switchgear, this solution is not compliant with the NEC. The NEC mandates a specific amount of clear working space around electrical equipment for safety reasons. This space is crucial for personnel to safely operate, maintain, and troubleshoot the equipment. The code specifies this clear space to minimize the risk of electrical shock, arc flash, and other hazards. The doors, in this scenario, are not considered part of the electrical equipment itself and therefore cannot be used to fulfill the working space requirements. The problem is that the doors could be closed, thereby obstructing access to the equipment and negating the required clear space when someone is working on or near the energized components. Consider the specific language in NEC section 110.26a, which addresses working space about electrical equipment. This section stipulates minimum depths of clear working space in front of electrical equipment, based on the voltage to ground and the conditions present. These conditions typically refer to whether there are exposed energized parts on one or both sides of the working space, or whether there is an insulated surface opposite the equipment. The minimum depth is prescribed to provide adequate room for a qualified person to perform their tasks safely. The installation of doors does not fundamentally alter the physical constraints of the room. With the doors closed, the working space remains at 2 feet, which is a direct violation of the NEC requirements if 3 feet is required. Even when the doors are open, they do not guarantee a permanently clear and unobstructed working space. There is still the possibility of someone closing the doors inadvertently, or of objects being placed in front of the open doors, thereby reducing the available working space. To achieve compliance with the NEC, the situation needs to be rectified to provide the required 3 feet of clear working space at all times. Several solutions might be considered. Firstly, moving the electrical equipment further back into the room, away from the wall, would create the necessary working space. This, however, might require significant modifications to the electrical connections and may not be feasible depending on the layout of the room and the existing conduit runs. Secondly, installing a permanent physical barrier to prevent access to the area in front of the electrical equipment could be considered, but this solution is rarely practical. The intent of the working space is to allow access for qualified personnel, not to restrict it. Thirdly, it may be necessary to relocate the electrical equipment to a different location within the building where sufficient working space can be provided. This would likely be the most disruptive and expensive option, but it might be the only way to achieve full compliance if the existing room configuration is unchangeable. Another important consideration is the width and height of the working space, as specified in NEC section 110.26 ATWO and A3. The working space must be at least 30 inches wide or the width of the equipment, whichever is greater, and must extend from the floor to a height of at least 6 feet 6 inches or the height of the equipment, whichever is greater. These requirements ensure that a person working on the equipment has sufficient room to move around and to avoid accidental contact with energized parts. Furthermore, NEC section 110.26b addresses the need for clear access to the working space. The entrance to the working space must be of sufficient size and located to provide unobstructed access to the equipment. In other words, personnel should not have to climb over or around obstacles to reach the working space. In addition to the working space requirements, there are other NEC requirements that may be relevant to this installation. For example, NEC section 110.26c addresses the need for illumination in the working space. Adequate lighting must be provided to enable personnel to safely perform their tasks. NEC section 110.26d addresses the need for dedicated equipment space. Space above and below the electrical equipment must be kept clear of obstructions that could interfere with maintenance or operation of the equipment. It is also worth mentioning the potential liability implications of non-compliance with the NEC. If an accident were to occur as a result of insufficient working space, the building owner and the contractor could be held liable for damages. Therefore, it is crucial to ensure that all electrical installations meet the requirements of the NEC. In summary, the installation with doors in front of the switchgear does not meet the NEC requirements for working space. The doors are not considered part of the electrical equipment and cannot be used to create additional working space. The installation must be corrected to provide the required 3 feet of clear working space in front of all electrical equipment. This may involve moving the equipment, relocating the equipment, or other modifications to the room. It is important to consult with a qualified electrical contractor or engineer to determine the best solution for achieving compliance with the NEC. Here are some further considerations. The specific voltage of the 2000 amp service is a critical factor in determining the exact working space requirements. The NEC provides tables that specify the minimum depth of working space based on the voltage to ground in the conditions present. For example, for systems operating at 151 volts to 600 volts, the minimum clear distance could range from 3 feet to 4 feet, depending on whether there are exposed energized parts on one or both sides of the working space. It is essential to consult the appropriate NEC table to determine the precise requirement for the specific voltage of the service. The 2000 amp service likely serves a large facility or a significant portion of a building. This implies that the equipment is critical for the operation of the facility. Therefore, any modifications or repairs to the electrical system must be carefully planned and executed to minimize downtime and disruption to the facility's operations. A thorough assessment of the existing electrical system should be conducted to identify any other potential code violations or safety hazards. This assessment should include a review of the wiring, grounding, overcurrent protection, and other aspects of the electrical system. It is also important to consider the impact of any modifications on the overall electrical system. For example, moving the equipment may require rerouting of feeders or branch circuits, which could affect the capacity or performance of the system. Selection of qualified personnel to perform the electrical work is crucial. The personnel should be licensed electricians with experience in working on large electrical services. They should also be familiar with the NEC and other applicable codes and standards. A detailed plan should be developed before any work is started. This plan should outline the scope of the work, the procedures to be followed, the safety precautions to be taken, and the schedule for completion. The plan should be reviewed and approved by a qualified electrical engineer or inspector. The electrical work should be performed in accordance with all applicable codes and standards. This includes the NEC as well as any local or state regulations. The electrical work should be inspected by a qualified electrical inspector to ensure that it meets the requirements of the codes and standards. Any deficiencies identified during the inspection should be corrected before the system is energized. After the electrical work is completed, a thorough testing and commissioning process should be conducted to verify that the system is operating properly and safely. This process should include testing of the wiring, grounding, overcurrent protection, and other aspects of the system. The results of the testing and commissioning process should be documented and kept on file. In addition to the technical requirements of the NEC, it is also important to consider the human factors involved in working on electrical equipment. Personnel should be properly trained in the safe operation and maintenance of the equipment. They should also be provided with the necessary personal protective equipment, such as gloves, eye protection, and arc-rated clothing. Regular safety meetings should be held to discuss potential hazards and to reinforce safe work practices. A lockout/tagout procedure should be in place to ensure that the equipment is de-energized before any work is performed on it. This procedure should be followed strictly to prevent accidental energization of the equipment. In the event of an electrical accident, a prompt and effective response is essential. Personnel should be trained in first aid and cardiopulmonary resuscitation. An emergency plan should be in place to address potential electrical hazards. This plan should include procedures for contacting emergency services, evacuating the building, and shutting down the electrical system. The plan should be reviewed and updated regularly. It is also important to maintain accurate records of all electrical work performed on the system. These records should include the date of the work, the scope of the work, the materials used, and the personnel who performed the work. The records should be kept on file for future reference. Regular maintenance of the electrical system is essential to ensure its continued safe and reliable operation. This maintenance should include inspections, testing, cleaning, and lubrication of the equipment. A preventive maintenance program should be developed and implemented to address potential problems before they occur. The NEC is a complex and comprehensive document. It is essential to consult the NEC and other applicable codes and standards to ensure that all electrical installations are safe and compliant. It is also important to seek the advice of qualified electrical professionals to assist with the design, installation, and maintenance of electrical systems. Ignoring the NEC requirements can lead to serious consequences, including electrical shock, arc flash, fire, and property damage. Therefore, it is imperative to take the necessary steps to ensure that all electrical installations meet the requirements of the NEC. The purpose of the NEC is to safeguard persons and property from hazards arising from the use of electricity. By following the requirements of the NEC, you can help to create a safe and reliable electrical environment. The NEC is updated every 3 years to reflect changes in technology and best practices. It is important to stay current with the latest edition of the NEC. The NEC is available from the National Fire Protection Association and other sources. There are also many training courses and resources available to help you understand and apply the NEC. The doors, even if they provide slightly more than 3 feet of clearance when open, do not address the fundamental safety concerns that the NEC intends to mitigate with its working space requirements. The risk of the doors being closed, the lack of a permanent and unobstructed space, and the potential for other obstructions all contribute to a situation where safe operation and maintenance of the electrical equipment are compromised. The correct approach involves a permanent solution that adheres to the letter and spirit of the NEC, ensuring the safety of qualified personnel who may need to work on the equipment.